go. And pull that back up. Well, there. All right, so I'm going to go ahead and draw my curve while y'all are drawing y'all's curve. How about that? Have you printed out any curves yet? Or are you tired of drawing curves yet? Okay, nobody's going to answer. That one's dead. I got to buy some more black Sharpies. So 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. And we've got 0, 1, 2, 3, -1, -2, -3. And our mean is 100. Standard deviation is 20. And they want to know, what is the probability of x being greater than 1/16? So I went ahead and wrote everything so I can minimize it. So there is my drawing. And hopefully y'all have Googled and got a drawing with the percentages and the 0, 1, 2, 3, and hopefully you printed that out or put it on, 4 to a page or 6 to a page, and maybe printed out 10 copies, because we're going to be drawing them until the last day of class. So that's what it looks like. I'm going to take my handy dandy magenta and we're going to draw 1/16. Well, so this is 100. This is 120. This is 140. And this is 160. This is 80. This is 60. And this is 40. Now, you're never going to be able to predict what your mean and standard deviation is going to be, so that's why I did that in magenta, and that's the only thing that you'll have to add to your curves if you do. I'm going to cut my video off so it maybe help with the bandwidth. And that will help you with, that's the only thing that you'll have to add to your Google curves that you printed out. So now we need to 1/16. Where is 1/16? Well, we know that this is 110, and we know that that's 115, because if this is 20, 20 divided by 4 is 5. So that'd be 105, 110, 115, and 120. So 1/16 would be right there. Now, we know that 34 divided by 4, I have no idea what it is, but 34 would be 8. So each one of these is 8. That's 8%, 8%, 8%, and 8%. So 13.5 plus 2.5 is 16. 16 plus 8 is 24. So roughly, by using the empirical rule, I'm going to say that it's 0.2400 to 2500. So that's what I think it is by the empirical rule. So now we've got to change, if you've got an older calculator, you've got to change 1/16 into a z-score. So I'm going to go up here. Z of 1/16 is equal to 1/16 minus 100 divided by 20. And that's going to be, and I think it's going to be around 0.76 as a z-score, because of the empirical rule. That's 0.75, so I'm going to say 0.76. So I think the z-score is going to be around 0.76. So let's see what it actually is. 1/16, that'll be 16 over 20 divided by 2 over 2, which is equal to, what is that? 2 the 8 over 10, which is 0.8. So your z-score at 116 is not I got 0.76 by the empirical rule, but it's actually 0.8. So if you've got an old calculator, you need to do 0.8 to 9999. And don't forget that this one down here is negative 9999. That's it. So we take our handy dandy calculator and we say second, bars, and go down to normal CDF. Now, if you have a new calculator, you don't have to change that to a z-score. You just have to do the 116 to 9999, mean of 100, standard deviation of 20. Okay? So if you have a new calculator, you're able to change the mean and the standard deviation. So I'm going to do like an old calculator and hit 0.8 and then 9999 and then paste. And enter. I said it was around 0.24 to 0.25. 0.2, I was a little bit high. 2119. And that's your answer. 0.2119. Now, if you have a newer calculator, you would type in the same thing, except you would put in a new mean and standard deviation. So I'm going to put in 116 to 9999 with a mean of 100 and a standard deviation of 20. And enter, and you should have the same thing. So that's a good question. Any questions on that one? 0.2119. I told you that most of this test would come from 7.1 and 7.2, especially 7.2. So there's an example. Next question. Determine the following graph can represent a normal density, and there's no graph there, so what is that? Skewed what? Could the graph represent a normal density? No. What is it? It's skewed what? Skewed right. Now, if you miss that question, don't what? Don't tell anybody. Okay, the probability to the right, in the probability distribution to the right, blah, 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 complete parts A through blah, blah, blah. Okay, first of all, I'm going to take this to Excel, and I'm going to show you what you should be able to do with this, okay? You can do it in the calculator if you want to. We're going to do it on the spreadsheet so I can get everything on the board. Is everybody with me? Okay, thank you. So I'm waiting for it to come up. Just give it a second. And you can copy it down. Everybody see it okay? You should be able to see the spreadsheet. And
Yes,
I'm
sir.
going to make it a little bit bigger. And I'm going to make this a little bit bigger. Or a little bit. And make this a little bit wider. And this a little bit bigger. Make sure everything's centered for y'all in my OCD. And make that underline and bold. Okay, so make sure you can see everything. I think that's good enough. The white background is kind of overpowering with that with my TV monitor, but I guess it's okay. All right, so first of all, what do you always do? You make sure you don't have any negatives or anything above 1. And what do you also check on a binomial distribution or a polynomial, a probability distribution? You check to see if that column on the right adds up to equal what?
1.
1. Thank you, Miss McCann. Okay, if that was Miss McCann, I think that's who it was. All right, so what else do you do? Well, they said you need to graph it, so let's graph it. Highlight the 2 and go to Insert. And I usually use a chart plot. And let's look at it right quick. Looks like I'm going to draw it. I'm going to do everything on my sheet of paper here. So I'll have the answers when I go back to the test. So it looks like we've got a little bit skewed right, just a little bit. Okay? So make a note that our probability distribution looks a little bit skewed right because we got this hump right here on the left. All right, so I'm going to get rid of that. Now what else can we do? Well, we can find the mean and the standard deviation. All right, now remember, let's go back to our handy dandy. What's the mean for a binomial or probability distribution? The mean is equal to the summation of what? X times what? P of X. And the variance is equal to the summation of X squared times P of X minus the mean squared. And the standard deviation is always equal to the square root of the what? Variance. Okay, now we covered this in 6.1. This is one of the first problems that we did in Unit 3. So you should be able to do this. Okay, I think we did a couple of problems, and I did it with the Excel spreadsheet, and I also showed you how to do it with your calculator. And we'll do it just in case you forgot. I'm so good to y'all. All right, X times P of X. And that's going to be equal to this times this. And I'm going to copy that down. And I'm going to copy this over. And that right there is my mean. So you need to copy that or paint it green. That's your mean. Make it bold. Dang, I'll put some squares around it. Dang old thick outside. There we go. There's your mean. I really can't stand. Hold on a second. I'm sorry. My OCD is really kicking in this morning. I need to take some medicine. Where's my Arial? Oh, that's a whole lot better. All right. So, anybody got any questions on the mean? All right, so now we got to find, let's go back to our handy dandy drawing. Let's find X squared times P of X. So I'm going to skip a line. I'm going to put X squared right here. X squared equals this number raised to the second power. And copy that down. And then X squared times P of X. So that's going to be equal to X squared times P of X. Make sure you pick the right one. Sometimes I pick the wrong one. Don't pick this one. Pick this one. And then you got to add that up. So And the standard deviation, we're going to put, I'm just going to go over here, put variance. Variance is going to be equal to this number, 40101, minus, parentheses, this number raised to the second power. And where did I get that? Right there, minus the mean squared. Oh, come on. Enter. That is my variance. And then what is standard deviation? Raise that to the 0.5 power or take the square root of it, whichever one you want to call it. Raised to the 0.5 power. So, let me write that down. My mean is equal to 1.6239. My variance is 1.37305. And my standard deviation is 1.17177. So that's all I can do with those numbers. So let's go back to the question. And it says, verify. I'm going to move this over out of the way for a minute. This is a discrete probability because each one, all the probabilities are between 0 and what? 1. Y'all can talk if y'all want to. And the sum, of the probabilities is equal to what? 1. And we said it was a little bit skewed left, right? No, skewed right. So which one of these looks a little bit skewed right?
B.
Good. The distribution, I think, has one mode. I can't remember if it's one mode or if it's bimodal. I can't remember. I can't remember which one it is. I think it's bimodal, I'm pretty sure. And it is a little bit skewed right. The mean, it says, do not round, so I'm going to just type the whole mean, 1.6239. And over the course of many games, you would expect the mean to be pitched per blah, blah, blah. Observed number of hits. I'm looking at in any number of games, one would expect the number to be the mean. I believe it's D. And round to 3 decimal, 1.171. 1.172. Sorry. Okay. What is the probability that you go to 2 games or 2 hits? 0.2891. 0.2891. What is the probability that a randomly set together player got more than 1 hit? More than 1 hit would be what? All of those added up. Or I'm going to take the 2 probabilities at the top and subtract them from 1. So that's going to be 0.1675 plus 0.3344. Add those 2 together. And that's going to be 9, 1, that's going to be 6, 7, 8, and 0, and 3, 4, 5. So 0 plus 1 games, or 1 hits, is equal to 5019. Therefore, 1 minus 0.5019 would be 0.4981. So that would be more than 1. 0.4981. And I probably got those two wordy problems, probably got those wrong. Yep, I got one of them wrong. I don't know which one I got wrong though. I have a feeling it's that bimodal. Let's say multimodal. Let's see what it says. That's the one I got wrong. So that means which one I didn't pick? One mode? Okay, got that right. So I must have got this one wrong down here. How many parts does this thing have? There we go. All right, so what we need to write down this. Over the course of many games, one would expect the mean number to be equal to the mean of the random variable. I knew it was equal to the mean of the random variable. That's why I accidentally picked this one. I just didn't think it would be over the course of many games in any number of games. So I guess you have to be a Philadelphia lawyer to understand the difference between over the course of many games and in any number of games. The only thing I would say as a probability instructor is any would not be a good, that's like forever. So that's the only reason I could see picking A over D. Capiche? So make sure you do over. Make sure you remember over on that one, because I really don't care about this. I care about the mean, the standard deviation, and what we went over. That's all I cared about. And it has one mode, and that's going to be the answer. Next. The length of time it takes college students to find a parking spot in the library parking lot follows a normal distribution with a mean of 3.5 minutes and a standard deviation of 1 minute. So I'm going to go ahead and draw my, so I'm going to draw my curve. Zero, 1, 2, 3, -1, -2, -3, 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. So I just drew my handy dandy drawing. We'll make it a little bit smaller so I can fit it on the page a little bit better. Okay, now I can't move it. There we go. All right, now I'm going to need to add I'm going to use a different color. I really don't like that magenta. It's a little bit too bold. 3.5 minutes with so it'd be 4.5, 5.5, 6.5, 2.5, 1.5, and 0.5. Okay, now I'm ready to address the question. Because all of this right here, all that says draw the curve. That's what that says. So now I'm ready to do the question. Find the probability that a randomly selected college student will take between 2 and 4.5 minutes. Between 2 and 4.5. Okay, here's 4.5, so that's good. And 2, we don't know where 2 is. We know that 1.5 to 2.5 is 1, so half right there. What would that be? Well, 1.5 to 2.5, half is 1. So that'd be around 2 right there. So I'm going to draw a line right there, which I think that's around 1.5-ish, negative 1.5-ish. But you're going to have to actually plug it in. So let's do a z-score in case you got an old calculator. That's going to be 2 negative, wait a minute. Yeah. I'm sorry, I was thinking out loud. Yeah, that's 2 seconds. All right, 2 minutes or whatever. All right, so that's going to be our actual 2 minus 3.5 divided by 1. So 2 minus 3.5 is negative 1.5 over 1. So that comes out to be about 1.5-ish. And if you wanted to change this one, if you have an old calculator, 4.5 minus 3.5 over 1 is equal to 1 over 1, which is equal to 1. So if you wanted to go from z-score to z-score, that would be negative 1.5 to 1. Okay, if you had an old calculator. So let's pull up our handy-dandy calculator. And let's go ahead and do second bars and normal CDF. Now, since the older calculator is the older calculator, I'm going to go with the older calculator. And if you've got a newer calculator, you go ahead and punch in whatever you need to punch in, and the answer will come out the same. I'm not going to do both because that takes up too much time. So negative 1.5, negative 1.5 to 1, and then I'm just going to hit, and with your normal calculator, you don't have the ability to change the mean and standard deviation. So your mean and standard deviation would look like that, and then you just hit enter. And enter. Now let me take my handy dandy empirical rule, and I'm going to guesstimate whatever 68. 34 and 34 is 68, and half of 13 or half of 14 is 7. So 17 plus 68. I'm sorry. Yeah, 7. 7 plus 68 is equal to what? 75? 7 plus 8 is 15. So I'm going to say it's around 0.7500 by the empirical rule. Let's hit enter, and it comes out to be 0.7745. So the actual answer is 0.7745. 77.5% that it's going to be between, hold on a minute, I got to pick up the pen, between the score of 2 and 4.5. So 0.7745. Let's go back to the, so 0.7745 is right there. And we can check that answer and we'll get it right. So far, I haven't seen anything. The only question I haven't seen is this one. And that the whole test is all what we just went over. So I'm going to take my handy dandy and I'm going to draw a number line on this one, because this is NPX. NPX, which means binomial. CDF means cumulative. The C stands for cumulative. Okay? Or binomial PDF, which means the P means precise, meaning equals. Okay? So let's draw this. We've got 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Now, our question says n is equal to 9. That's where I got the 9 from. P is equal to 0.4. Therefore, Q is equal to 0.6. And you only need to know that if you use the formula, which we're not going to use it. We're going to use the calculator. And they're asking x is less than 4. So x is less than 4 means 0, 1, 2, 3. Do I include 4? Yes or no? I need somebody to answer yes or no. Do I include 4?
No.
Do I include 4? No, you do not include 4, Hubert, because that's not an equal sign. That's less than. So I need to do cumulative 0, 1, 2, 3 because this always reads to the left. The cumulative always reads to the left of the number. Here's the number. You can't include 4, so you're just going to get 3, 2, 1, 0. So you would type in binomial, second vars, binomial CDF, because you want cumulative, you want all of these right here. Reads up to that number. And that's going to be N 9.4 and 3. And that's your answer. So pull up our handy dandy calculator. Second, vars, binomial CDF, which means cumulative. And make sure you don't skip it. There it is. Trials, 9. P, 0.4. And X is 3. Now, if you have an old calculator, when you pull up binomial CDF, it's going to give you this parenthesis, and you type in 9, comma, 0.4, comma, and 3, and close parentheses. And that's going to be, the answer is 0.4826. 0.4826. .4826. Now we have went over just about all the questions that make up this test, especially the normal distribution. I don't think we've covered a uniform, so I'll see if we can find a uniform. Okay, I'm going to go ahead and show you this one. There are 2 college entrance exams that are often taken by students, Exam A and Exam B. The composite score on Exam A is approximately normally distributed. Okay, we'll do this one because this one's a little bit different from the questions that we've done so far. You got to do 2 graphs. So make sure you leave room on your paper for 2 graphs. Okay, so the first direction say draw the curve. The composite score on Exam A is approximately normally distributed. I'm going to need y'all's help to do the calculator on this. Make sure y'all calculate, because I'm not going to do all of those decimals in my head. I'm not going to do that. 0, 1, 2, 3, -1, -2, -3, 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. Okay, and I need y'all to take your calculators. I need somebody, Miss McCann, do you have your calculator?
Yes, sir.
Okay, I want you to do the left side. I want you to subtract. Miss Stewart, do you have your calculator? Or Mr. Muzan, do you have your calculator?
Mine is dead.
Okay, Mr. Muzan, do you have your calculator?
I do not have mine.
Okay, this is only math class. Okay. Nobody has a calculator on their phone. Nobody has a calculator. Okay. All right. So, Miss McCann, I need you to take 20.2 and subtract 4.7 on the left-hand side. Just keep doing it. So, I'm going to put 20.2 in the middle. 20.2. And I'm going to try to do the right-hand side because I can add better than I can subtract. So, that'd be 24.9. 24.9 be 29.6. 29.6 be 34.3. And if somebody wants to take their phone and check those for me, Miss McCann, what's 20.2 minus 4.7?
Let me do the last one. Give me 1 second.
Okay.
$15.5.
15.5.
The next one is 10.8.
10.8. And the last one.
6.1.
0.1. I need you to check that last one for me, or check these to make sure I'm right. Okay, now while she's checking that, we'll draw the second one. Okay, I'm going to draw it in black, but I'm going to use a different color for the numbers. Zero, 1, 2, 3, -1, -2, -3. And we're going to use these. I'm not going to rewrite everything. Well, it's the same percentages. And this one says, suppose you score, let's see, what does it say? The composite score for exam B is 1035 with a standard deviation of 201. So that's going to be 1236. Somebody help me. 1236 plus 201 would be 1437. And 1638. Somebody check those for me. I'm not going to even try to subtract it. So somebody could take your phone and subtract 1035 minus 201, then that number minus 201, then that number minus 201. I better just do it myself, because y'all may not have a phone. So 1035 minus 201 is 834. Minus 201 is 633. Minus 201.
432.
Thank you, 432. Now check all my numbers. Now, what have I just done? I just took out that. So you can mark this out. You can mark that sentence out. You can also mark this sentence out. So just mark those out because you're done. Now, suppose you scored 29 on exam A. So I'm going to take my blue marker. And I scored a 29. Hold on. I scored a 29 on exam A. So 29 would be right in there. And a 1239 on exam B. 1239 on exam B? Which exam did you score better on? Justify the reasoning. Well, I can tell you right now you scored better on the first one because that's a 1.8 versus a 1.2. But we'll go ahead and see what the area is because they want to see what the area is out of 100%. What did you score on that one? And on this one, what did you score? 1239. Excuse me. I got the Corona. Corona, Jamaica. All right, so there you go. So that means you need to take your handy dandy calculator. Let me ask you, Miss McCann, since you're the only one with a calculator, do you have a newer calculator or an older calculator?
I have a newer one, a TI-84.
Okay, so you're able to change the mean and the standard deviation?
Yes, sir.
Okay, well, you go ahead and do that. And I'm going to do the X. I'm going to do the Z-score for those that have an older calculator. So I'm going to change 29. 29 minus 20.2 over, the standard deviation is 4.7. So I'm going to do that in my handy-dandy phone calculator, since I have a phone. And that's going to be 29 minus 20.2 divided by 4.7. Y'all check me. I got 1.87, and that's right because there's 2. So 1.87 would be about right. So for those with an older calculator, you would do normal CDF, and this is negative 9999 down here. Negative 9999, comma, 1.87. That's if you had an older calculator. The green would be 1239 minus 1035 divided by, what is it? 201. And I'm going to take my handy dandy calculator. 1239 minus 1035 equals, divided by 201. And that's 1.01, which would be correct because there's 1 right there and a little bit over that. You could argue 1.02, but I'm going to say 1.01. So you would do normal CDF parentheses negative 9999 to 1.01, and we're going to do that right now. And then you'll be able to tell, but you can tell by the Z-scores that your first one is a little bit, this one up here is a little bit better. But we'll see what it has to say. So, second, bars, normal CDF. Okay, it's already got negative 9999 in there. That's defaulted. And upper is going to be 1.87. And since I have an old calculator, I can't change those. And I said, let's see, I think it's going to be, let's see, 34 plus 50 is 84. And then 3/4, let's see, 13 divided, or 14 divided by, well, really 12. 12 divided by 4 is 3. So that'd be 3 times 3 is, I'm going to add 10. I'm going to say 94. About 94, roughly. 0.96925, which is 0.9693. So my blue comes out to be 96.93%. 0.9693. 90, really 97%. So let's do the green. And I'm just going to hit second entry. And I'm going to do negative 9999 to 1.01. And of course, I can't hit my dadgum 01.
On A, I got 0.9694.
That's fine.
Might have done something. Okay.
And of course, it's screwed up because I'm trying to, this dadgum menu bar is down here and I can't get rid of it. It won't disappear. We'll see if I can move it over. Okay, I can't get rid of it. So let me see what I did wrong. Go to. Okay, has it got an extra decimal? Comma. 1 point. Should be 0, shouldn't it? There. Enter. 0.8438. 0.8438. Well, I don't know about y'all, but last time I checked, a 97 was better than an 84. What do y'all think? Somebody tell me which one says that. We know it's exam A, right? Exam A. So it's either C or A. I think it's C. Because of percentile. We're dealing with what? Area, percent, probability. Those three things are the same thing. So I would say C. And we feel good about ourselves. Now make sure you try that problem twice. Okay? Try to find a homework problem like that one. It would be in 7.2. That is a good homework problem. Okay? Now, let me see if there's anything else I haven't shown you, because if you can do that problem I just did, you can do any of the Chapter 7 problems. NP what? NPX. Is this cumulative or exact? That means I want y'all to answer. Is it cumulative, CDF, or is it binomial PDF? It's binomial PDF, Hubert. Thank you, class. Binomial PDF because it has an equal sign. So you would type in binomial PDF 10.6 and 7. So I'm not going to do that. You can do that. I think that's an easy question. Next. Find the z-score for which the area under the normal curve is 0.4000. We did this one in class, or at least the other class if you watch the videos. Okay? This problem, you use the inverse norm. Okay? You need to find the area. And I'm not going to draw the curve. I'm just going to draw. We know this is 50%, right? So 40% would be right along somewhere in here. I don't know. Let's see, that's 50%. And let's see, 34 divided by 3 is 11. So you'd have 3 11s. So I'd say 11 from 50, 10 from 50 is 40. So there's 40% right there. So this is 0.4000. Now again, the reason I put the area in 4 digits is to differentiate from the z-score, because they're asking you for a z-score. They're giving you an area. Okay? area under the standard curve is 0.4000. So that's what they're asking for, and they want to know this guy right here. This is where you use second vars, and we did this in class, inverse norm. And you just type in 0.4000, and it will spit out your z-score. Now, of course, I think it's going to be, that's negative point, I'd say negative 0.4. I'm going to say negative 0.4. That's by the empirical rule. We still got some time. All right, so let's see what the calculator says.
Negative 2.5.
Okay.
0.25.
Okay, hold on. Second vars. I got to show y'all how to do it. Inverse norm. Thank you, Miss McCann. Point area is point. I wish that menu bar would go away. 0.4. I'm not going to put all the zeros because I'm not going to fool with that menu bar. Now, what side are we looking at? Left. Because, see my hatch marks? They're on the left. If it was asking for the right, then it would be right. If it was between, then it would be center. So I'm going to put left and paste and enter. What'd you get? Negative 0.2533. I said 0.4, so that's around that same area. Remember, the empirical rule is a, rule of thumb. It's not it's an estimate. It's not anything in concrete. So I got negative 0.4, but the actual answer is negative 0.25. And remember, z-scores are to the second decimal point. So negative 0.25. You might see a couple of questions like this on the test because I put a couple of those because those are pretty simple. Just remember, this is not a z-score. This is an area. That's why I put 0, 0 on the end of it. So you'll remember that's an area. If you're given an area, you have to use what? Inverse norm. If you're given an area, you have to use inverse norm. Next. And I'm just gonna go through. I'm not going to do any more problems. I'm just going to show you. Suppose the lifetime of light bulbs more normally distributed. What does this mean? Draw the what? Draw the curve. Less than 60 hours. 50 hours or less. Between 57 and 62. Less than 46. So there's 4 different questions from 7.2 right there. Okay, there's no difference in these than the other 7.2 questions we did. There's just 4 of them right here. Find the area under the standard normal curve between 1.5 and 2.5. Well, heck, we did that a while ago with that other question. I think it was 1, or I can't remember, but that's that. You don't even have to do any math here. You just have to punch it in the calculator. Find the area under the curve between 1 and 2. Okay, that shouldn't be hard because 1 and 2 is 13.5. So which one do you think it is by the empirical rule? It's 13.5, 0.13, whatever, 50. Which one do you think it is? You don't even have to do anything there. You just have to think of the empirical rule. But type it in the calculator under normal CDF and you'll get that 13.59. Empirical rule, you get 0.1350. Suppose that a recent poll found that 65% of adults believe the overall state of moral values is poor. What do you see here? N is equal to 450. P is equal to 0.65. And what else they give you? They're going to give you X. Okay, it says, for 450 randomly selected adults, compute the mean and standard deviation. Okay, mean and standard deviation. I'm glad. This is the one I was looking for. This is the last one. This is the only different problem I haven't covered. All right, they're asking for mean and what? Standard deviation. Mean and standard deviation, and they've given you N is equal to 450 and P is equal to 0.65. Therefore, Q is equal to 0.35. So what's the only thing you can do here? The only thing you can do is the mean is equal to NP,
Priority 1 message
and the standard
on secured
deviation
channel.
is equal to the square root of NPQ. That's the only thing you can do there. And this is the only problem on this test right now that I haven't covered. So mu is equal to 450 times 0.65. Somebody do that for me. What's 450? I'll do it. What time's class over, Miss McCann? Really, we can sit here another 30 minutes if y'all want to, but I've got another class coming up, but y'all ain't got to go anywhere. Let's see. 450 times 0.65. I got 292.5.
292.5.
All right, there's one answer. Now, this is NP, so all you got to do now is multiply this by Q. Take that, multiply it by Q. I'm just writing this out to the side. And take the square root of that. So I'm going to multiply by 0.35. And then I'm going to raise that. I'm going to take the square root of that. I'm going to raise it to the 0.5 power. I get 10.12. So the mean, the standard deviation is equal to 10.12. And that should be your answer. The mean is, round to the nearest whole number, so that's going to be 293. And the standard deviation, round to the nearest tenth, is 10.1. Okay, so for every 290, I'm looking. The mean is the minimum number that would be expected overall state. For every 450 adults, the mean is the number that would expected would be the overall state. The mean is the maximum number. I don't think that's right. For every, the mean is the range. No, that's not right. I would say D, but I'm not sure. Would it be unusual if 310, okay, what do you do there? Well, you got a mean and a standard deviation, don't you? What do you do if you have a mean and a standard deviation? You draw the damn curve. Mean is equal to what? 293? All right, somebody take, I'll do it. 293 plus 10.1, 303.1 plus 10.1, 313.2 plus 10.1, 323.3. 293 minus 10.1, 282.9. What?
And then 272, 272.8.
272.8. And then what?
262.7.
Thank you. All right, and they asked the question, they said, would it be unusual if 310 of the 450 adults surveyed believe that well, where's 310? 310 is in here. Normal, remember, empirical rule, 2 standard deviations is what? Normal. Would it be unusual? No. Now, the only thing I think I've got wrong is that B part. I got it. All right, so write down that so you'll know which one it is, so you won't have to think, because some of these, they word. The mean is the number of them that would be, well, that is a good word right there for probability. Expected. Okay? You're not going to find the mean, and the mean is going to be the answer. Okay? The mean is the number of them that would be expected. Okay? So I'm just going to carry it out to the last part. Let's see, we've got, what time's my next class start? I think it starts at 9:35, so we got another few minutes. All right, next, and this is for the other class too, the 123. All right, so I want you to do this one. Find an inverse norm of 0.0900. So do that with your inverse norm. Well, y'all don't have a calculator, so I'll just pull it up. Second, vars, inverse norm, 0.09.
Priority 1 message coming in on secured channel.
0.0900, and I'm going to paste, and I'm going to hold up a minute. I want to see if it says to the left or to the right. To the right. So I'm going to go back, second, vars, inverse norm. I was hoping it'd keep it in there. Yeah, it did. And I'm going to change it to the right. So that's going to be a big number because 0.09 is a little bit. So it's going to be, well, yeah, it's going to be on the right side. Like probably 2-ish, somewhere in there. 1.79 or 1.80. 1.80 would be your answer. So I'm going to put negative 1. Wait a minute. That says left. I thought I hit right. Did I not hit right?
0.34.
Hold on. I thought I hit right. There we go. 1.34. Thank you. Okay, so it looks like we're repeating now. So, okay, we did this one. We did one like this one in class, I think. The number of chocolate chips in an 18-ounce bag of chocolate chips normally distributed with a mean of what? Draw the curve. And they're asking you, this is the same question that you had a while ago with 4, same question. So this one you just have to draw a picture between, fewer, that means to the left, more, that means to the right. What is the percentile rank? A bag contains 1475. That's exact. So that'd be to the left. And if you've got a new calculator, you don't have to do anything but punch it in. You don't even have to draw a curve. All you have to do is do 1252 for the mean, 129 for the chips, for the standard deviation, and then type in lower bound 1100, upper bound 1400. Fewer, negative 9999 to 1125. 1225 to 9999. Here, negative 9999 to 1475. If you have an older calculator, you have to change each one of these numbers to what? Z-scores, and do the same thing. Suppose a brewery fills a machine that fills 12-ounce bottles of beer. It is known that the amount of beer, normal distribution with a mean of 1238 and a standard deviation of 0.4. Find the probability between 12.28 and 12.34. Again, that's, if you got a new calculator, you would type in 1238.04, lower bound 12.28, upper bound 12.34. If you have an older calculator, you're going to have to change 12.28 to a z-score and change 12.34 to a z-score and do the area between those two z-scores. As you see, a lot of these are chapter 7. This, oh gosh, this is one of the first ones we did in chapter 7. 50 and 10, between. So it's going to be between, it's going to be C. That's between. And if you've got a new calculator, between 56 and 68 with a mean of 50 and a standard deviation of 10, boom, pops it out, 4 digits. If you've got an older calculator, 56, change that to a z-score, change 68 to a z-score, put it in your calculator, spit out 4 digits. No, just keep going, yes. The graph, there's the uniform distribution. Let's do that one. That's the only one we haven't done. Uniform distribution. That means I'm going to draw it. And it's going to be uniform. That means the area inside is 1. And they want to have a base of 30. 0 to 30. So therefore the height is 1/30. It's always 1 over that number. Okay? The probability that the friend is at least 9 minutes late. Well, 30, that would be 15 right here. That'd be 15 minutes. Half of 15 minutes is 7 minutes. So there's 7. So I'm going to say 9 is 7 to 15. Half, let's see, that's 8. Right, or 7. Half of 7 or half of 8 is 4. So 11 minutes would be right in there. So I would say 9 minutes will be somewhere in here. So there's 9 minutes. And they want to know at least, they want to know this area right here because your lowest number is 9. So what's 9 to 30? What's that distance? 21. So this distance right here is 21. 30 minus 9 is 21. And your height is 1 over 30. So area, this area right here is going to be area at 9 is equal to 21 over 1 multiplied by 1 over 30, and that's equal to 21 over 30, which is equal to 7 over 10, which is equal to 0.7000. 70%. And that's what you would type in. It says round to 3 decimal places, 0.7000. And that's it. That's all. I ain't got any other questions, but I'll go ahead and look at the last 3. That's bonus. Okay, now this one you should be able to do real easy, because what is this right-hand side supposed to equal?
1.
Okay, so 1 minus point, what's 1 minus 11 cent, 32 cent, and 34 cent? Well, 34 cent and 32 cent is 66 cents. That's 77 cent. So what's 77 cent from a dollar?
Priority 1 message coming in
23
on
cent.
secured channel.
And that's one we've already covered. 50 and 7, and you're going to do 33 to 63. So you see that there's only like, what, 6 questions, and it's just repeating those 6 questions. Who's got a question? All right, we've kind of went over. I don't know what time it is right now. Isn't class over at 9:25?
Yes, sir.
Okay, so I hit it right on the nail. Okay, so now y'all can do the test. Now, I wasn't able to get through the 120 yesterday with the test, so I'm going to finish with them tomorrow. So you should be able to watch that video also and maybe get some more questions. Okay, so you can watch that video. I'm going to finish with them tomorrow. I started with them yesterday. So what I would do if I was you, if you still want more practice, watch yesterday's 120-23 video. It says Unit 2, Part 1. And then, what is that? Oh. And then watch today's video or tomorrow's video, and then watch this video if you need to. And then you should be able, between the 2 tests, the 123 test, excuse me, and the 120-10 test, that's 2 test videos that you can put together. You should be able to ace this test. Any questions? All right, y'all get out of here and have a good day, and I'll see y'all tomorrow or Thursday. Okay?
Okay. Thank you.
All right. Be
I
good.
have one question.
Yes.